Have you ever encountered a cryptic error message that left you scratching your head, wondering where your code went wrong? It is a common moment of frustration for any programmer, feeling lost in a sea of technical jargon. Understanding a debugging stack trace means learning to read a chronological record of the function calls that led to an error in your program. Think of it as a detailed forensic report, mapping out the sequence of events right up to the point of failure. This crucial tool immediately tells you where the problem originated, allowing you to pinpoint and resolve issues much faster. The core mechanism behind a stack trace lies in how computer programs manage function calls. When your program executes a function, it pushes an entry onto a data structure called the call stack. This entry contains information like the function's parameters and the return address. When that function calls another, a new entry is pushed. This continues until a function returns, at which point its entry is popped off the stack. If an error occurs, the stack trace prints the entire current call stack, showing each function that was active, from the most recent to the one that started the chain. To effectively use a stack trace, start by looking at the top line, which typically describes the type of error or exception. Below that, you will find a list of function calls, each on its own line. Always begin your investigation at the very first line of your own code appearing in the trace, moving upwards from the bottom of the list. This line represents the last piece of your code executed before the error was triggered, which is often the most direct source of the problem. Follow the flow backward, examining the context of each preceding function call to understand why it led to the problematic state. A valuable insider tip is to pay close attention to the file names and line numbers provided in each entry. These details are your direct map back to the exact location in your source code, enabling you to navigate quickly without guessing. Often, the true bug is not in the line where the error manifests, but in a preceding function that supplied incorrect data or an invalid state to the function that eventually crashed. This process of tracing back through function calls is sometimes called backtracking or unwinding the stack. By mastering the art of reading stack traces, you transform what once seemed like an indecipherable error message into a powerful diagnostic tool. It empowers you to efficiently locate the root cause of issues, enhancing your debugging skills and ultimately making you a more effective and confident programmer.